This video is going to go through a related rates example that's actually from our textbook, but I'm going to fill in some gaps for us. So these related rates problems are tricky at first, so don't get frustrated if you're having difficulty with them. But there are a few things that might make it a little easier. First, it's a good idea to list everything you're given in the problem and also what it is you're being asked to find. And you should use appropriate notation. For example, if I know that Sebastian is running at a rate of 5 meters per second at t equals 3, then I would write down ds dt, for Sebastian's running rate, is 5, and I could put meters per second, at t equals 3. Okay, so that would be information I would want to write down. Then you need to find an equation that relates all the variables being discussed in the problem, and sometimes you need more than one formula. And if a second formula is needed, then you're going to want to use substitution to create one formula. Next, you're going to want to use implicit differentiation on both sides, and you're going to want to differentiate with respect to t. So most variables in your equation are going to have dr dt, dx dt after them. And then once you've done that, you'll solve for whatever it is you're being asked to solve for. Let's look at the example from your book on the next slide. Again, this is from page 151 in your textbook. An airplane is flying on a flight path that will take it directly over a radar tracking station, as shown in figure 2.36. The distance s, so this distance here, is decreasing at a rate of 400 miles per hour when s is 10 miles. So you're given an instantaneous rate of change. So that's definitely something that we want to write down that we're given. So ds dt is negative 400. The reason it's negative is that the distance is decreasing. So anytime you're decreasing, you're going to have to remember to use negatives. It's asking what is the speed of the plane. Well, that's similar to velocity, except you'll remember that speed is the absolute value of velocity. And so that number, if we were actually, when we solve for it, we're going to find the velocity. And so since the plane's distance is also decreasing, the answer is going to originally be negative. And you can just scroll down here and see that the answer turns out to be negative 500 miles per hour. But since we're talking about speed, we have to take the absolute value, and it's 500 miles per hour. Okay, so I'm being asked to find the speed of the plane, which is a rate. And so since my plane is on this path here with an x on it, my rate would be dx dt. And I want that rate at the instant when s is 10, and they're finding that x is 8 because they're just using Pythagorean theorem, because this is a right triangle, which is going to come in handy. So if you look back at the steps, the first thing we were supposed to do is to write down everything we're given and what we're being asked to find, so they've done that. And next, we're supposed to come up with an equation to relate all of the variables being discussed. So since we have a right triangle, a Pythagorean theorem would be a great formula that would relate all three of these sides. So we have x squared plus y squared equals s squared, which translates to x squared plus 6 squared equals s squared. Now, you might be wondering why they don't just fill in 10 and 8 here, but hopefully you can realize that if you did that, you would just get a true statement, 100 equals 100, and that would be useless. So you can only substitute in these values once you've differentiated both sides. I'll say it again. You can only substitute in these given values once you've differentiated both sides. The only reason I'm allowed to substitute in 6 is that that is a constant for this entire problem. Even though s is changing and x is changing at all times, 6 is staying constant. That height of that plane is not changing. So 6 is a constant, which means you can put it into your formula. Okay, so we have our formula. The next thing we're supposed to do is differentiate both sides with respect to time. So since this is x squared, when I differentiate it, if I were differentiating with respect to x as we've normally been doing, then this would just be 2x dx dx. And dx over dx is 1, which is why we were never writing that, because it's always 1. But now I'm differentiating with respect to time. So everything has to be with respect to time, which means it needs to be something dt. So this is 2x dx dt, which is how they got that, and then plus 0, which is why you don't see that, and then 2s ds dt. Okay, so then they're just isolating dx dt because that's what we're being asked to find. Okay, and so we have this equation, and now that we've differentiated both sides, we're allowed to fill in the values that we know. And so the answer is negative 500 miles per hour. That's the velocity, but we were being asked for speed, so it's 500 miles per hour. I hope this helped to clear things up a little bit. These are difficult, I understand that, and so we will definitely go through several examples in class and on homework. I hope this helped a little bit, and I'll see you tomorrow.